Okay, let's begin the class. So, good afternoon, everyone. Yeah, we are here for our program, the second week. I'm not going to do any long introduction because I believe the introduction is done. And the orientation, unfortunately, I wasn't here. I have another assignment already programmed, so I have to honor that. And unfortunately, but I'm happy to see. I mean, you everyone here, those online as well. I'm so much excited. I cannot see you, but I know you can see me. So I believe all of you know my name already. Dr. Michael, you can just call me Dr. Mike or Dr. Michael. That's fine. I'll be easy. Yeah, and I'm here for. Okay, yeah, I'm here. Okay. Yeah. So today we are in for anatomy for central service technician. Anatomy. You will be wondering why do we need anatomy? Are we medical doctors? The question is, I mean, the answer is no. We are not medical doctors. But we need good knowledge about anatomy, central service technicians, because the work we do, we set the OR, the pressure room. That's why the doctors are. When they make a call to central staff, they make certain, records using some medical terms you should be able to understand what they mean. That's the reason this chapter is very critical. Interestingly, it's one of the chapters that students find very difficult. Let me be very real. Chapter 2 that we had on Sunday last week, where you're exposed to those big. This chapter, the next chapter, these are the chapters that students run away. So when I meet my students the first time, I tell them, you're not going to like me, or you're not like me, but because I'm the one teaching those chapters, you're not going to like it. And with my experience teaching this for so many years, you see students stopping the class in chapter 2, 3, and 4. Once they're able to survive, they don't run away. Well, once we enter chapter 5, they are happy. Hooray! They're happy. So please, I'm telling you, and the students honor, never make that human mistake, human error, by leaving because of last week, and today, and tomorrow. You'll be able to survive. Once we go through that, then we are entering, the chapters that are kind of, interesting. It is very interesting in a way. Do we understand that? If you have any questions, just feel free to ask anytime. And those of you who are joining, my name is Dr. Michael Bimpe. You can just call me Dr. Michael or Dr. Mark, and that's fine. So anatomy of, now, let's see. I hope nobody's running away, right? Is somebody running away already through the door? All right, nobody's running away. Well, let's look at this introduction, the role of central service technicians. What do we actually do? We provide instruments and support services. And you can see some instruments here already. When you go to the field, these are instruments that you are actually going to handle. Tons of them, different instruments. These are the basic ones. So we make these sets, ready and available to the operation room for surgeries. And also we support the surgical team in the operation room. Without central sterile technicians, the operation room cannot survive. If Donald Trump, our president, we also have a surgery, and we cannot there to make the instruments available.
I want maybe 8 bar. But right now you what?
Yes. If Joe Biden, I believe most of you are from Ghana, if the President Mahama or the Pope whatever want to have celebrate, and then we don't make the instruments available to come. So we support the operation room. And also, it is very important for us to understand the human body. Now, we are working on these instruments to be used for human beings. We are not working in the the animal hospital. We are working in the human hospital. So we need to understand the human body. You understand me? In case you're working in the veterinary, the animal hospital, then we will need to understand some of the parts of the animal system as well. But this one, we are dealing with the human body, and therefore we must understand that. And also, when you understand these terms, it actually helps you to communicate with the OR, the head nurse or the OR nurse manager. The supervisor can call. Hi, SPD, we need tonsillectomy tray. To voicemail. The person you're trying to. Now, they can call, but they need to go straight. So how do you communicate with them if you don't understand tonsillectomy or tracheotomy? Then you are going to GYN section. Now, so when you understand, you know straight away, oh, tonsillectomy, tracheotomy, let me go to what? ENT section. Vaginal hysterectomy. Oh, sorry, abdominal hysterectomy. Let me go to the GYN section. No ENT. You understand my point? So understanding these things is very important. Facilitates surgical requests. Of course, when you understand this, it will make it faster for you to respond to their names. And also, study of anatomy and physiology begins with cells, tissues, and of course, as the basic structure. I mean, in your high school, those of you, of course, I believe everybody here has high school, basic biology, you learn about cells, tissues, organs, and of course, body systems. And today we are going to make systematic, analysis or understanding of to see how these things function, how they function. Now, you can ask questions at any time. You don't have to wait for me to finish the class before you ask, so you can just ask questions anytime. Role of central service technicians. Role of central service technicians. They are very much important in the surgical interventions. Sometimes they'll rush a patient in that this patient needs surgery within like 2 hours. Without the surgery, the person will die. We are there to provide the instruments. I remember one of the hospitals, our director is aware of that, but I don't want to mention the hospital. They brought a patient, the patient swallowed something and it was, hungry somebody. They needed a tracheotomy tray. That tray was not ready. By the time the tray was ready, the patient died. I was in that hospital, and our director was also in that hospital. So he knows what I'm talking about. But when it comes to this kind of things, we don't mention the hospital. If it's a good thing, I'll mention to fry. The patient died. So our manager then made it mandatory that anytime we saw tracheotomy tray, it is a top priority to must be done. So that's why we have this there. That of course, we help the surgical team and also understand the human health, the facilities, all this. So this is very important. Now, major body systems and surgical procedures. We are going to talk about the skeletal systems. So what happens is that we have cells. The collection of cells will now form a tissue will now form organ, and then goes to the. So that's how they go. And we are going to learn about these, cells, tissues, organs, and with the skeletal system, we're going to look at how bone, joints, cartilage, how they support.
Adia.
Yes. Ibrahim, mute your.
Yeah. If you want to ask a question, you can.
Ali, can you please mute your microphone?
Yeah. All right. Let's try to have our microphones muted. If you want to ask a question, you have the liberty to ask at any time. All right. So, and then we also have the nervous system. We are going to understand how the systems work. Nervous. Panic when there is like a gunshot and pow, pow. How does the body, coordinate, send message? You begin to see everyone here running, helter skelter. The body communicates immediately, and that's what we are going to understand. Endocrine, happiness and joy, reproductive system, urinary, respiratory, digestive, and circulatory. These are the systems that we are going to learn today. Now, structure and functions of cells. Now, I want you and everyone, let's go to page 31, page 31. Page 31. Page 31. And those of you who are online, I want you also to go to page 31. So you see, we have cells, tissues, and organs over there. And then let's have some understanding about the cells over there. They are the basic unit of life. The human body is comprised of more than 1,000 trillion cells. So all of us here, each one of us, is made up of more than 1 trillion. I remember I was teaching this in upstate, Ithaca, and then I had a pregnant little lady in my class. Then when I said we are comprised of more than 100 trillion, I could tell from kind of facial expression that she was smiling. And I just mentioned her name Vita. Because I mentioned the city, I don't want to mention her name. What's running through your mind? I said, well, you see me, right? So I have more than twice of that. I burst into laughter because she's pregnant. So she's thinking that she herself has 100 trillion, the baby also has 100 trillion. So interesting. Yeah, so everyone has more than 100 trillion cells. And the cells, listen to me very well, that is the basic unit of life. Let me explain. These cells are human, are living things surviving. Meaning that if 100 trillion cells die, you, the human being, you also die. Because your life is dependent on the cells. Does that make sense to everyone?
Yes.
Correct. Because you are alive, because those cells, form, and the brain alone has more than 100 billion in a way. So you are surviving because all this come together, they are surviving. They breathe, they eat as well. We are going to learn that. So when they all boom, then you, the human being, boom, you are there. So it is defined as a basic unit of life. Our life is dependent on the cells. Does that make sense to everyone? Those online, if you have any questions, feel free to ask anytime. And that'll be my job, to explain those to you. They vary in size. Now, the point two, I want you to make some mark around it because I'm coming to explain something. They vary in size, shape, and function depending on their location in the body. They vary in what? Size, shape, and function. Okay, the eye is to see, right? The ear is to what? Hear. So the cells in the ear, that function will be different from the cells in the eye. Because the eye is to see, so those cells in the eye should help you see. Those in the ear should help you hear. That's a function. You understand that? Yes. I think it's very simple, right?
Yes.
As a matter of fact, I want to make this very simple for you to understand. So I'll be, flipping through the side of the book so that you understand this very practical. So that when you go to make your personal study, you just smile because it has been digested in the class. Function, what about shape? Now, you see my hands, right? My finger is elongated, right? Or let me see my leg. Again, let me use the eye. The eye is sort of spherical, round, right? So the cells in the eye should have that kind of ocular or kind of, round kind of shapes, so that when they align, it will be round. But this one should be kind of off and elongated so that when they are apart, does that make sense? So their shape also varies. Their function is the one I talk about first, using the ear to hear, audible to hear, to see, and then that's fine, right? We can understand these things. So feel free to ask questions anytime. So that's how they are. And also, their shape, the function and the shape goes just like, and now. So that's how cells are. And let's talk about the other one over there. They are so small that they can only be seen with a microscope. We cannot see them. Very tiny, very tiny. They are microscopic in the sense that the naked eyes cannot see them. They have to be magnified and a microscope for them to be seen. And it's very, very interesting how these things are. And of course, go to the next one. Within each cell are cells or structures called organelles, microscopic organs that perform. Within the cells,
I love myself.
let's be on meals. Okay, with the 100 trillion cells, again, each cell also has some smaller things again called the organelle, and they perform specific functions. So, the cells that are in the eye to see, each one has a cluster of organelles. They perform specific. Those that will help you to take oxygen. Those that will help you to excrete. Sometimes you look up and something is out here. Very interesting, right? Yes. That's how nature is very wonderful. When I'm teaching diverse students, I don't mention God or Allah. I don't want to offend anybody, so I just say nature. Yeah. That's how wonderful nature is. You understand me, everyone? Correct. Now, so we are going to review the basic structures of cells, understand the function, various tissues, learn about the activities of different organs, explore the role of cells, tissues, and organs in the body, and of course, identify the surgical. Now, identify surgical instruments accurately. We are going to see the surgical procedures that are associated with, some of these, systems, especially. And it's very interesting. Yeah, improve surgical outcomes through better instrument and standard. Now, so we have talked about cells. What do we say about cells right now? Basic unit of life. 100, more than 100 trillion. They have minor things in them called organelles, and they perform specific function, and cells vary in shape, structure, location, and of course, function. Now, so from cells, we are moving to tissues. Let's see how tissues are formed. But please, let's understand something here. Let's go to tissue. Now, on this, on page 32, on page 32, tissues form when two or more cells that are similar in structure. Please underline the word, underline the two words. Similar in structure and function. Please underline that. I know what I'm telling you, because when we come to organs, we are going to say something different. Those online, please underline the word similar in structure.
Please, the page.
32, page 32, and the tissue. Underline the word similar in structure and function. Similar. The word similar is very key. Similar in structure and function. So, let's talk about this is two or more cells. Okay, but they must be similar in what? Thank you. So the eyeball that's spherical round, and for us to see a cell there cannot join a cell in the ear that will help to hear to form a tissue. Does that make sense? Because their function is not the same. That's the reason I said you should underline the word similar function and structure. Again, the structure. The cell in my leg, that's elongated. Cannot be the same as the eyeball that's spherical round. Because structure-wise, they are not. Please, anytime you are trying to, define tissue, don't forget the word must be similar in structure and function. That's the core, the heart of your definition. Does that make sense? I don't know your name yet. Don't worry. This time I know your name. It's a very small one. I'm the majority one. I know it. So I'll begin to your name. I know your names along the line. Are you okay? Okay. I was wondering if she's lost. If I'm lost, let me know, okay? Yeah, if I'm lost, I'll discover you right here. All right. That makes sense to everyone, right? So the similar. Now, this is how they are formed. So you see, formed by joining similar cells. 4 primary types, we have epithelial, connective, muscular, then nervous. These tissues are very, very important in helping us to, survive. When you look, the epithelial covers, the body's external surface. So the skin is an epithelial and it's a tissue. Then you have the connective. You have the connective also there. That helps us to store energy. Then we have the muscular tissue that shortens and contracts. That puts us into motion. Just imagine somebody wants to run. You start, muscles will begin to move. That will set you into motion. Yes. So before you move, some muscles must move somewhere to propel you into motion. Run into motion, and that's what happens. And also we have the nervous tissue also there that stimulates us to move. Now, it's wrong. Maybe I didn't touch it for some time. Okay, let's get it out. Okay, yeah. So that's about that. So again, we continue, and now it is the basic unit of life already, and we have about more than 100 trillion and the various size, shape, and functions. I explain all this, right now. And you also know that they vary in size, shape and function, and of course, they are so much tiny that the naked eyes cannot see them. The naked eyes cannot see them. They can only be seen under a microscope. They have to be magnified, microscopic organs with cells performing specific functions. And also, you'll be wondering, you see this include respiration. They also breathe. That's why we say it's a basic unit of life. So the same thing that you, as a human being, you are doing, individually, they are doing the same thing. You understand me? So respiration, nutrition, energy production, waste elimination, they eliminate waste, the product, and then they reproduce. Reproduction, they reproduce. If they stop reproduction, then you are dead. So sometimes when you have a disease that can overwhelm the production of the cells, it means that the cells just be reducing and finally you are dead. They're very unfortunate. So the cells reproduce as well. So basic unit of life is the cells, right? And they also perform the basic functions of respiration, etc. They do all that. Living cells come from other living cells. Yes, we cannot have a cell coming from a dead cell. How? Human beings, when we are dead, you don't reproduce, right? So it's just a common sense that we cannot have cells reproducing when they're dead. So living cells reproduce, and this is basically something basic. Do you understand? Yeah. Please feel free to ask questions. Any questions at this point? No, right? So we carry on, right? Great. So this is how how a cell is composed of. This is how a cell is composed of. We actually have three basic or fundamental, three key. We have what we call the nucleus. The nucleus is there, and then we have the cell membrane, and then we have the cytoplasm. These are the three key. There are others, trust me, but these are the three key. The cell membrane actually covers the cell, provides a kind of cushion, kind of a protective layer. But everything the cell is doing is from the nucleus, which is the brain center, the power. Just like a human being. When you go to the hospital and they pronounce your brain dead, you are dead. Once they pronounce your brain as dead, you are dead. And it's a miracle. And I've never, well, I mean, I'm not trying to sound blasphemous, but the fact is that I was seeing somebody that they declared brain dead and the person comes back to life. I was sick. That's why I said maybe that's a miracle. Yes. So just as the human being, where your brain is the powerhouse, your whole person is the brain. Once your brain is there, you are there. The cells also has this key. So at least, be able to know the nucleus, the cell membrane, and the cytoplasm. I mean, the cytoplasm is around the nucleus to protect it, you know, so that it will be around you like a gel, you know, kind of cushion. These are the three key components. So you can write them down, those who are writing the nucleus, the cytoplasm, and then the cell membrane. The nucleus, cytoplasm, and then the cell membrane. These are the three key. Don't get me wrong. Others are also very important, but the focus is on this three. You know, questions and possible questions and other things will be centered around this three. Yeah. Everything that is very, very important. But there are also now we talk about this, the organelles. I said they perform specific function. So each cell has what we call the organelles. Again, and we talk about that already. Now, tissues. I talk about the tissue run out by going to page 32, right? Yes. What did we say under tissue? Everyone, tell me. Those online, tell me. What did we say about tissue? Sorry? Well, you're right. You're talking about maybe the epithelial tissue, the type of tissue. That's good. Yeah, the tissue side. What do we learn right now about tissues?
That they are similar in
Exactly. What's the name, please? Huh? Mosha, thank you. Yes, of course. Similar. When two or more cells similar in function and structure, then they form, of course. And I was saying that because the eye, in terms of function, is to see, the ear is to hear. A cell here cannot come together to form a tissue. Yes. But you can have a cell here to come together to form a tissue. That makes sense, right? You're also right, because you were giving me the types of tissue. That's why I said yes, of course, I will accept it. Any questions so far? Now, so cover the external surface of the body and also lines, body cavities like mouth, nose. So when you open your mouth, for example, the line, the nose, the ear, the whole body, and connective tissue. So that's the epithelium. Then the connective tissue provides support and stores energy. Examples include bone fat, blood, and cartilage. What is cartilage? You know what's cartilage? Cartilage. Not for free.
It's when one or two bones joining together, the cartilage is in between.
Okay.
It's not a gel, right?
Okay, I'll accept it. That's fine. Yeah, that's fine. Accepted. We are going to move on with that, okay? As a basic. That's a good job done. All right. Yeah, bones, protect, bones protect, support, and then for the shape, and then fat keeps the body warm. I mean, fat, let's be a minute, please. Yeah. Fat keeps the body warm and pushes organs. One thing about this is that, you see, when we move forward, we're going to learn about amylase, proteins, and lipids. For now, I mean, we're just hearing that. Come on, it's talking about our body breaks down fat. And one interesting thing in science is that, you see, when the body breaks down fat, only little of the fat is taken away. It will break it, send it somewhere to store it somewhere. Yes. And when you are growing, the body is not able to, do that enough. That's why when you are growing, you see more fat, building up. And it keeps us warm. This is why those who are actually huge, very fat, anytime they are kind of like they need more air, and the little heat they cannot withstand. Yes. Blood transports oxygen, removes waste. We are going to see that the oxygen that we need is blood that takes it through, and then also the cartilage provides fluid and support. We're talking about all that along the line. Let's come to organs. Now, let's go to the book again. Page 32, 32, organs. Organs, let's go to organs. Organs are formed when two or more, look at the word, please underline the word different. These are not similar. Different. Underline that word different. Those online, please, we are reading under organs. And I want you to underline the word different. You see, under tissue, you underline the word similar, right? Organs, we are talking about how? Different. Very interesting. Now, we are talking about when two or more, right? Tissues kind of come together, but then they are different. If you talk about, let's say, reproductive organ of the male, as a system, we'll be talking about the reproductive system, or we are going to talk about the testes, the penis, etc. But when we talk about an organ, we are looking at where two or more, but then they are different, but they are coming together to give you a specific goal. So when I get here, I like to talk about the practice because that helps people to understand. So don't get confused. If you've experienced, this is what's not get confused. Tissue and organ. One is similar, one is different. Not in my class. I don't think anybody here will be lost today. And those are, because remember the two words. With tissue, similar. With organ, different. Different both. So when we go to the reproductive system of the male, you are going to see that the penis, the function. The testes manufacture the sperm, etc. So the testis is to manufacture. The penis is to drive the semen. So you see, they are different, but they come together to form reproductive system. And the idea applies to the organ that way. Am I making sense to everyone? Yeah, so that is how this is carried out. So now, one good example there is the brain. And if you take the brain, for example, we are going to see how each component of the brain, even the tongue, your tongue over here. This one, the front, is what Different from the main. Yes. There's cells and etc. Receptors around here that only taste sweet, sour, etc. But they come together to form the tongue as an organ. But those receptors are from different. You understand that, everyone here? Great. That's what we are doing. Now let's continue. So that's about organs. The brain is the primary receiver, organizer, and distributor of information. So what you are doing here right now, sitting here in this corner, you are getting the information from me. The brain is the one processing the information. It is the powerhouse, receiver, organizer, distributor. If I see a snake here right now, is the eye that has is the eye, the brain that this is something that is like this way, then the brain will tell the whole body that run away. It is danger. It's the brain. So when you see something, it's the brain that is interpreting everything. Does that make sense to everyone? Yes. So it is the primary receiver, organizer. If there is power here, that's sure. It's the ears that get the power, not the brain. But the ear will carry to the brain. Brain, I have papa. What to say? The brain will tell, listen, that thing here is not reggae music. Reggae music is not reggae music. It is there. Run away. Does that make sense? So it's the brain that interprets. So the reggae music, the brain will tell you, come on, move your body down. The papa, the brain will tell you, run away. It's about there. So the brain is the organizer, interpreter. And then I hope everybody's hearing me, right? Let me hear your voices, online people. Hello, are you there? Yeah, muted. Well, I hope everyone is listening to me anyway. All right. The heart pumps blood throughout the body. We know that. And the stomach, of course, the digestive system. And then we have the skin, covering our body. All right. Fatia Hassan, right? I think I see you right there. All right. Thank you. He's talking. Now, let's come to body system. So you see, we move from cells, tissue, organ. Now we are going to look at the system. Okay? The system. Now, let's look at body systems. Page 33. A body system is a group of organs. Body system is a group of organs from both that work together to carry out a particular activity. So when we say the reproductive system of the male is no longer the testis as an organ, the penis as an organ, but then they come together to carry out a specific activity to let the new baby form. Does that make sense, everyone? When we talk about female, the ovaries, the fallopian tube, the vagina, etc., they also come together to perform specific activity. So collection, they come together. I believe I'm getting everyone very clear, right? Correct. So we have definition of system, a group of organs working together, carry out specific activities. They are interdependent. So we have the digestive system. They want to just the cow normal. But without the ties also, the car, the engine can be the best engine, the car will still not move. So they're kind of interdependent. Does that make sense to everyone? Correct. So they work together. That's the idea. That's the reason you see the word interdependence of body systems. Each system provides specific functions. None are independent of others. They work together, as I said. The car tires. You can have the best car tires. If the engine is dead, the car will not move. That's simple as that. And also on an online level. Then we also have the role of the reproductive system, suction in maintaining life, and we are going to talk about the next chapter overview. Now, so overview of body systems functionality, body systems functionality. We actually have groups of organs working together. We said that a collection of organs form a system. A collection of organs form a system to carry out a specific action. Like each provides, specific bodily functions. And again, you see that systems work together, and of course, they're able to maintain our life. Systems essential for maintaining life. And again, information on major body systems, common procedures for treating issues. Along the line, I think somebody sent message. Okay. All right, that's fine. I don't see anything. Maybe I need to scroll down. Oh, that's good. Yeah, I'm fine. Yeah, I was just responding to
Yeah, she said 1 minute ago.
yeah, some messages and then yeah. Okay, yeah. Okay. So yeah, it's a skeleton, right? Yeah, to talk about that. Okay. Yes, the skeletal system. So now we are in the systems now. How many of you know this? I like it so much. Snail. You know snail?
Snail.
Yeah. Yeah. You know snail, right? Everyone?
Yeah.
Yeah. You? Yeah. Okay. Thank you so much. One time I had that. I'll let you that when I come back to Ghana. Yeah. Okay. So when we come to the skeletal system, I like to use the snail as my point of focus to explain what I want to take, to talk about. Now, if you see that snail that goes, have you ever seen in the rural areas? Or maybe you grew up in the city, so you didn't see it. So those of you who grew up in the kind of, the outskirts, like the villages, as I grew up, when the car kind of maybe walks on the snail and breaks the shell, you see that sometimes the snail is not there, but then the snail cannot move. Everyone here today, let me tell you how to take this one up. You, right? You couldn't even have work. In your hand that you can't even do it. You just be there like this. So we are able to move as you see me swing my arms because of the bone of the skeletal system. Otherwise, the body will just be a mass of immovable something that's there. Object. It's a bone. It's a bone. The skeletal system. So the skeletal system is very key. It gives the body shape and support and allows movement. It protects vital organs. Look at, for example, here, protects vital organs, and inside, you know what we have there, right? Correct, heart and whatever. Yeah, and store calcium. Yeah, calcium. Gliding joint, types of joints. We are talking about bones, so we should see all about bones. Then we talk about the gliding joints, where they allow head to lower like this. Head to lower like this. So there is something here that's allowing us to kind of, you are, yeah, sorry.
What's the name?
Or the gliding joints. Gliding joints. allow head to lower. Then we also have the ball and socket. Look at the way, the ball, yeah, socket, yeah, something fitting. So allow circular. And look at my arms. Look at my arms, like twisting it, yeah, it's fitting into it. And then we also have the pivot, allow turning like this. Pivot like this. Then again, you say that very good. You also have the the calculating like the this kind of soft.
So we
Oh, that's what I wanted to say. I think 2012 I was teaching a class and somebody used that word. Oh, sir, don't be good. I'll never forget this.
Can I ask first?
Yeah, right.
I want to know the penis.
Okay.
Is it muscular or a cartilage?
Oh, this is a very good question. It should be muscular. Yeah. If it's about cartilage, oh no. I think women would die. You do respect the ladies. Yeah, I think so.
Yeah. Muscles.
Yeah, muscles, yeah. Yeah. Okay. Our main interest now, when somebody gets, those of you, well, I don't know, well, the men, they like soccer, right? And it is like movies. So the men, when you hear that this footballer has a bone fracture, blah, 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 these are all bones, right? So we want to look at the surgical procedures that involve. Well, we still have this, here. I'm attaching the joints, and then, so let's go here. Surgical procedures. Now, in the book, let's go to the book. Let's go to the book. Page 33. Page 33. I want to read something under the skeletal system. You see something, we say most bones are made from cartilage. Have you seen that?
Yes.
Under the bullet points. Most bones are made from cartilage, but through a process known as ossification, cartilage is sometimes replaced by bone. Cartilage is flexible, ferrous, etc. Now, our interest here is to see the surgical procedures that go with this example. So let's go to page 35. 35. Page 35. Let's go up there, up. Page 35, up there. Examples of surgical procedures involving the skeletal system include craniotomy. So last, very good. Excellent. So you learn chapter 2 already. You learn all these, terminologies. I mean, the preface, the root, the suffix. You learn about, craniotomy. Make an incision in the skull. So the head itself is like kind of bone, right? So anytime they want to access the brain, they have to make an incision. That is, what we call the craniotomy. So that's one. Then we also have anterior cervical fusion is also there. They have posterior lumbar interbody fusion. Then we have the open orifice. Orifice is not very common. Your procedure. For some reasons, that procedure is very common. What's this? Let me see this line right here. Now, so those are the surgical procedures that, and then I think I jumped over that. Bone composition is made up of tissues and minerals, bones. So when you go to the pharmacy, over the counter, you see a lot of vitamins. They tell you, the mineral like bone, especially when you are aging, your bone is becoming very weak. When you are aging, your bone is becoming very weak. That's why older people normally get fractures when they fall. They get, They'll tell you that some minerals, will help you. The two principal materials, we have the cortical and the compact bone, and then the spongy, the cancerous bone. Then we have the cortical bone, dense, strong, contains calcium and phosphorus. Then we have the spongy, is porous. So this is how. Now, marrow fills, bones with blood vessels and nerves. When I was very young, chicken, I like the bones a lot because when they kind of, you break the bone, it's kind of some sweet, things inside the bone. Yeah, the bone marrow. Yeah. Not only that, when they make like soup and then it goes in and then it mixes with the marrow. I like it, so much. Yeah. So the bone is not very good. And then you have the surgical procedures. That's what we talk about when they try to repair, these bones. If there is a fracture, and you try to, repair these bones. You have bone structure, surgical procedures involving the skeletal system, and then we have, we are going to, talk about them, the craniotomy, as we just read in the book, opening the skull to access the brain. Yeah, when they want to access the brain, they make an incision, through the brain. And then we have anterior. When you hear the word anterior and posterior, excellent, that's it. Yeah, that's it. So anterior cervical fusion, now remove the disc, putting pressure on the back neck. Then we also have, posterior. And again, that is the front. Now we also have this we call open reduction internal fixation area. Yeah, it's a very popular procedure in the US when you're working with surgical cell processing. Totally arthroplasty. Arthro, right? Arthro. You also know what plasty means. Plasty. Yeah. That's a suffix, right? The plastic, and then the arthro is, of course, a root, right? Correct. So that's it. Then we have the total hip also. Then we have the external physics and then hip pain. So all these things are talking about bone. All these things are talking about bone. Then we have the muscular system. Yeah. So on the skeleton, please let's go back. On the skeleton here, over here, on this skeleton here, then you have the muscles now going to form on that, skeleton to give us like a true look of how a human being looks like. And animals also form something. If you go to the American Museum of Natural History, in the first grade, you see a dinosaur, very huge dinosaur over there, the skeleton there. And American Museum of Natural History is the first street. It's one street. When you think the E or the D. 72nd? No, 71st. Well, it's okay, after all, it's big, so maybe it's yeah. But it's okay, it. That's it. So it forms on it. So what's with skeletal system for body movement? And again, if the flesh is formed on the bone, before you move, you see that, look at those who run. When they stand, their muscles are, but once they begin to move, look at how the muscles are activated. So when the muscles set into motion on the bones, then the movement begins. You cannot walk. Yes. So the muscles are very key. A number of movement of materials through the body and maintains body temperature. Yes. You can feel cold or you can feel the heat. Now, types of musculature, we have the skeletal, muscles, they are attached to bones. Yes, you have the skeletal muscles, they are attached to bones. They control consciously. What means that they attack, you have to command them to move. For example, if I stand here, if I want to move, I said then I can move. That's what they say consciously. Then you have the smooth muscles. Now, let me talk more about the smooth muscles. You see, the smooth muscles, they are the opposite to what? The skeletal. With the skeletal, you have to command the muscle to work. But with the smooth, you don't need to command them. They are working when you don't even command them. When you are sleeping and you are breathing, you know that you are breathing. When you wake up alive, you don't have to tell the heart to be pumping. It's pumping. It's a smooth muscle. So muscles that work on their own, without your command, they are called smooth muscles. Doesn't make sense to everyone. If I put something in my mouth and it goes into my stomach, I'm not going to tell my stomach, you have to digest it. It will digest by itself. Whether I like it or not, it will digest. So they're called smooth. The smooth ones act or work without our instructions. But with the skeletal, we have to command them to work. That's the disparity.
How about the urine?
Urine, you can only hold it up to some point. After that, you cannot hold it. Yes. Yeah, that's that. So types of muscle tissue, we have the skeletal, we'll talk about that. Then we have cardiac muscles. That's also involuntary, the heartbeat, as I said. You don't have to command the heart. It's working all the time by itself. Then we have muscle fiber requirements. Well, of course, they store energy from food and oxygen from breathing, oxygen. So that's some of the things that they do. Now, muscular system function works with the skeletal system to enable body movement and also facilitates. I said all this already. So the muscular, they attach to, they work in conjunction with, of course, the skeletal. That allows us to move. Without that, you cannot move. Facilitates movement of materials through the body. Then we also have the muscle activity during sleep. Over 600 muscles in the body, including for the skeletal, must remain active. Look at that. When we are sleeping, they are active. And about 400 of them are skeletal. With the skeletal, we said, well, we have to command them. Meaning that the remainder of 200, they are working on their own without our conscious command and remain very active. The examples of muscle functions, heart, muscles contract to pump blood, and then you see that. When you go to your doctor, they're checking the temperature to breathing. The lungs, you see, kind of opening, correct, opening and contracting. Then you also have the digestive tract muscles, move food and fluid. So these are the muscles, that work their arm. Then we have types of muscle tissue. We have the skeletal again. We have the smooth. We talk about all this. Then we have the cardiac. This slide is just a summary of what we talk about. Yes, the smooth is the one. The smooth here is the one that we say. The smooth is the one that we say. Will work on its own without our command. With the skeletal, we have to command them to work. Let's command them to work. Then we have the energy and function of muscle fibers, energy and oxygen requirements. So when we eat food, we get energy from it. That's why when we are let's assume you are fasting. You are fasting. Let's say you haven't eaten from, the whole day, from 12 midnight of the day before into like today, around this time 3. You see how weak you are, right? Sometimes you want to know, you have to brush your not very weak. Once we eat food, right there, instantly we begin to give that energy. We also get oxygen derived from environment when we breathe. Oxygen is very key. We are alive because we breathe oxygen. We take oxygen into our system. Remember, the cells that we talk about, we said the cells, basic unit of life, more than 100 trillion cells. And of course, the cells also take oxygen. We said, the organelles, they perform specific functions for the cell. So the cells also get what we call the break. They get oxygen. And movement and support, maintenance of posture and body position. for it to be able to stand, for it to be able to stand and walk, able to stand and walk. Oh, correct. Maintain of posture and body and production of body heat. Yes, the body must have, yes, some level of temperature requirement. Exactly. If the temperature is not there, doctors will say no, something is wrong. If the temperature is too much, especially when the COVID came, 2000, when you go to the hospital, they check your temperature first at the entrance, to make sure if it's elevated. If the temperature is elevated, that's like a warning, a signal, as a fever or something. And so all this in muscles and etc. Make sure that we have. Now let's look at the surgical procedures involving the muscular. Fasciotomy is the fibrous membrane, capital muscle. We call that fasciotomy. Herniorrhaphy, repairing cavity wall or muscle layer. The muscles can line up like it is. There is this animal, what's the name? Specific animal, when I was a kid, there was a hunter that was on it, and like you see the muscles like as thread, yeah, like that. When this is kind of this damage, they can do what they call repairing cavity wall / muscle layer. They can do a kind of herniorrhaphy if there is a kind of a rupture, tear. And also rotator cuff repair, RCR, repairing muscles and ligaments of shoulder, of shoulder if there is some kind of inflammation of pain or some kind of discomfort, like they can repair.
How about shoulder dislocation?
Yeah, they do that also. If there is shoulder, they will go there. First of all, you have to see it. Arthroscopy to see the extent of it, and then you have to restore. Bring it back. Then we also have methods. We have an anterior. Again, posterior and anterior, you are okay with these two terms. And then we have muscle biopsy. What do you know about when you say biopsy? What do you know about biopsy?
Biopsy?
Yeah, biopsy. Try. Yeah, biopsy. Try. When you say biopsy, is when they take, part of, part of, whatever, to pathology, to pathology. You take a piece of, of an organ, a specimen, that's how it's called, a specimen. Then send it to pathology, but they're going to study, Let's assume that you're having some kind of something in food, and they don't know. They take a piece of it. Depending on where, so that they go even inside you. To take just a piece of, a piece of that organ, and send it to pathology to study. It's okay. That's a biopsy. Normally, usually it's a minimally invasive procedure. It's not like a big surgery, just you do it and then you can come home, similar kind of thing. The nerves. Look at the word nerve. I am nervous. I am panicking, nervous. Nervous system. Nervous system, yes, the one that communicates. Correct. It communicates. That's the whole system. Coordinates and carries messages between body parts. So, again, let me go back to the example I gave first. Let's assume that we hear a gunshot outside, right? It's not the ear that, it's not the eye that heard it, it's the ear. The nervous system is a kind of wiring. It connects I mean, just like this building, you see wiring all around, right? So there is a wire from the ear, getting the pop outside, carries it to the brain. Instantaneously, the brain will analyze that. And again, my example first, it's not reggae music. It's a hostile sound. Then the brain also tell the foot that move quickly. You understand me? So you see how wiring from here, tap out, not reggae, it's a gun, food. You see, nature is so wonderful. What I'm talking right now, it's not like, yeah, okay, let me send it, I'm sending the brain. Okay, I'm sending the brain. Okay, brain, you wait, let me analyze. I'm analyzing 5 minutes. Okay, food, let me say, you are dead already. The gamma will come and kill you already. That's the reason I use the word instantaneous. Punches straight to the brain, analyze, boom, you are gone. So within a twinkle of an eye, the processing is done, the action is taken. That's how quick it is. Yeah, to the brain. To the brain. The brain is the interpreter, the analyzer. Yes. So within a twinkle, like a microsecond, everything is done. Now, yes, quick. So godliness encourages messages between the body and enables awareness and reaction to environmental changes. Then the central nervous system consists of the brain and then the spinal cord. Look at that. So with the nervous system, you have the central one, which is, of course, the brain for the key, the spinal cord. Now, covered by protective membrane called meninx. So the brain is covered by a protective layer that cushions it in a position so that it will not be hitting the scalp inside. Yes, correct. And of course, continuous and body's control center and information storehouse. Good experience you had when you were like 15, 20 is stored in the brain, the information warehouse. So also if you something bad happened to you, self-store, long-term memory, you can retrieve it. And so that's the body's control center. Now the brain structure, the brain is divided into cerebellum, then the brain stem. Cerebellum, then you have the cerebrum, then the brain stem is actually over here. That's a key. The cerebrum manages nerve impulse and controls. And then we have the cerebrum manages nerve impulse control, voluntary muscles, and interprets senses. See? Then we have the cerebellum controls muscle coordination, balance, and posture. Then we have the peripheral nervous system, coordinates and carries messages between all parts of the body and the enamels and whatever. So whatever is happening in your environment, the brain, the central nervous system, the brain is part of it, key part of it, because it's the one that is going to interpret, analyze, tell you that, listen, this is very good, this is bad. Then enables awareness of the environment, and then complex series of nervous tissues similar to electrical wiring. In fact, when you go to the book, you see how, you know, let's go to page. Let's go to page. The nervous system. Let's go to page 37, 37. Well, let's go to 38 instead. 38, page 38, 38. Page 38. Figure 3.19. Figure 3.19. 3.19. We see the wiring of the body, right? Yes. let me ask you something. A needle, very small needle, if it should pierce here, you know that something has pierced you. Why? Because of that wire. Correct. The wiring, the communication, something on. It's not a good sweet touch, it's a bad touch or piercing. The body goes round. So that's how the nervous system works. It's located everywhere. That's why when something should happen in the body, you feel it right there because it carries the information. Coordinates and levels are what is on the environment. Then runs, from the brain, spinal cord throughout the body. And that figure that you have seen, tells you a lot throughout the whole body. Controls body activities, allows response to stimuli. But some stimuli like something, like a command. Automatic reactions like blinking. You'll be surprised that if a house fly, I'm talking about it's coming quickly. Thank you. Those are very fast. That's how the system is designed. And then we also have currents, electrical messages from the brain, and spinal cord, and so on. So, and this is the central nervous system. We have the central nervous system, then we have the peripheral nervous system. The components of the central nervous system, the brain, we talked about this, the spinal cord. Then we have the protective membrane called.
Excuse me, Professor.
Hello?
We are having issue with the sound.
Oh, really? I think you even sent. I think you sent that.
Let's check what sound are we using today. Click on the microphone. Yeah. Yeah, click that. Yeah, choose the. Who's the link? The link here is not selected. Okay, choose the second one. The full. The full. Yeah.
This one?
Yeah.
Okay. Can everyone hear me now? Online, Zoom, remote?
Is it better now?
Yes.
All right.
Okay. Let's try that. Hopefully it works out. Let me know. Yeah. Okay. Let me know. All right. Yeah.
Yes.
Functions of the central nervous system, that's body's control center. We talk about that, the storehouse of information. It keeps a lot of information and spongy and complex. In fact, brain is very spongy. If I've ever seen the animal brain, that will help you. Kind of gray, not all that white, kind of very close to white or gray color, and very, 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 very strong, complex. And the information, research has shown that human beings use only about 5%. Research shows that we only use about 5%. So that means we are not using about 95%. That's why it's good to be reading be able to use the brain, because we have a very huge capacity of the brain, but then we are not using it. That's about that. Okay, yeah. Okay. Have I gone back? Okay, yeah, right here. So the cerebrum over here, in the picture you can see, is the biggest. The largest part of the brain. Manages nerve impulses for thinking. Of course, it should be the biggest because every thinking that you are making is done by that aspect. So it should be big as well. So largest part of the brain and nerve impulse of thinking, speaking, and remembering. We're going to recall information to remember, done by the cerebrum. Then we also have the cerebellum, and of course, which is here, the brainstem attached down here. It's the second largest. Even when you look at the picture, this is the biggest, right? And this is also quite big. Yeah. the second largest part of the brain, located below and behind. Yeah, it is first of all below because these are below and behind. So the description is not very clear. Below and behind, below and behind, and of course, adjust motor impulses for muscular coordination, body balance, and posture, helping to be able to, and then the brainstem is, the one that's like, located at the base of the brain. Yeah, and then the brainstem goes down to connect with the spinal cord. Yeah, and then peripheral nervous system branches out from the central nervous system, connects to other parts of the body, and also involuntary body processes. For example, heartbeat is part of it. Yeah, heartbeat, and then peristalsis, all this in during the heart. Then the conscious mind control, direct control over certain nerve. If you have something that's warm, very hot, you touch, let's say it's very hot, it will give you a signal, then you lift your hand out. All those things. Example. And we also have, like for example, waving a hand, but I can decide to wave a hand, not wave my hand. All this is a part of it. All this is part of it. Now, let's come to the sense organs. The sense organs. Well, when we talk about the sense organs, we are talking about the eyes, ears, nose, tongue, and skin. They are the sense organs because they help us to, send information to the nervous system. The eyes. If you see a cobra right there, because the nervous system. Send it to the brain.
The fucking chair. I forget to turn off like the micro and then clear up palitaria. So I was like,
No. Oh, some cacas. Bad smell. Oh. Tongue. I don't like this too soft. I like the sugar, the vanilla, the sugar. Yeah, to tell you. Then the skin. When somebody should give you a very hard-edged you want the soft tongue. So, of course, eyes, ears, nose, tongue, and skin are necessary. Accessory structures of the nervous system respond to stimuli such as light, sound, taste, and of course, chemicals, heat, and pressure. So those are the same. They make us, feel our environment, whether something is good or it is hostile. It can be light. If you have a light that is too bright or too dim, they'll communicate. And then you have the eyes. Let's give the eyes vision, focusing light, rays to produce images. Focusing light rays to produce images. So I stand here and then I look into that direction. Then I see that, something there called Heckland. That's water. Something above there on the table. These are instruments. Well, I can't drink that, but I can drink the one below. So those things help us to draw image. They let us see the thing and we study the brain. Remember that the sense organs work in conjunction with the heart. The central nervous system, the brain especially, that will interpret. So if the eyes see this, what is that? The eyes should see that it is something, then the brain will interpret that, that is water. You're feeling thirsty, so go for it. So again, they work hand in hand. They work hand in hand. And then we have the three layers. The sclera, that is the protection. Then we have the choroid, that's the nourishment, and the retina, light sensitive cells. Yeah. So sometimes if your retina is damaged, they'll see what they can do. Maybe some light, or some surgery. Sometimes they even do laser surgery for the eye, right? Do you know anybody who has done laser surgery for the eye? Do you know somebody? Well, they do those kind of things. Yeah, so all those things. Then we have the components. We have the cornea, the iris, the pupil, aqueous humor, then we have the vitreous humor. These are all the components. The good thing is that the board exams, like HISPA, HSPA, they actually don't ask questions like the pure biology kind of questions. They ask a few questions relating to the surgical procedures that are involved in this area. That's what we are interested in. The doctors, the nurses, they are interested in that. We are in the instrument area. So the surgical procedures, that's what your focus is. With my experience, you should be having about 3 or 4 maximum questions on this chapter in the board exams. Chapter 2 also maybe about 3. The combining files, that you learn about. For example, the like to ask a question, that the combining files. Learn that, right? Chapter 2. Don't tell me no. I know you're instructor John Bosco. I know you very well. I know he will surely teach you that. There is no way John Bosco will teach you chapter 2 without telling you about the combining files in chapter 2. Combining files. Oh, correct. Yes. So there are a few questions. And then chapter 4, that will be treated tomorrow. Also some few questions, when we come there. So again, don't run away from this class. After tomorrow, that's from next week, you should begin to enter into the nice into the nice areas. Then the nose, I talk about the nose, the tongue. And then we also have so these are the surgical, procedures again, because we talk about the brain, the central nervous system, that's why we still have the craniotomy here again. We have the craniotomy opening into the scalp. And then a carpal tunnel, you see, the hand over the compression, the pressure you can. Oh, right? Oh, congratulations. Oh, so you should know this very well, right? Yeah, okay, that's very good. I like that. Yeah, so, to release pressure. And then the ulnar nerve transposition, decision at the elbow area, your elbow area, they do this corneal transplant, extraction, cataract extraction with an implant. Those are like the eye. Want to hear something about the corneal transplant? Those kind of surgeries, for example, corneal transplant, cataract extraction, like when you are aging, that's when you begin to so. You normally don't see young people going for this when, like the eye. After 40 and a half. For this time, yeah. Then we have the endocrine. Now, role of the endocrine adapts to environmental changes, hormones. Can you imagine the day that you are so much excited and alive? What happened to your system when you're so much excited? What happens to you? You feel like you are walking on top of the world, right? Yeah. Why? Certain hormones are running through your system. The happy hormones are running through. So also, when something bad happens to you, may God forbid, you lost a dear one. Something very bad. It's like your life or your wealth has come to a standstill. Sad hormones also released. So the body must find a way to neutralize, to adjust. So adapt to environmental changes, hormones influence metabolism, growth, and personality. So interaction with the nervous system. Now, brain triggers endocrine glands. So again, he said, it's the brain that interprets everything. So something bad happens to you. May God forbid you lost a dear one. You just heard the information power. The brain analyzes that, this is bad news. And then the system will begin to respond to it. So we're talking about response, how the body responds. And here, anytime we hear about the endocrine, we're talking about the hormones. It's all about hormones at this point. So hormones influence metabolism, that's growth, and personality, who you are. And also, interaction with the nervous system. Again, that also responds. If you hear Okay, you are running. Your heart beat, like that. Hormones. Release coming down when you're hiding somewhere. Yeah, that's what happens. So the brain triggers other glands during threats, and hormones prepare the body to fight. Sometimes you don't know that you are strong until somebody like very hostile, you don't know where your strength comes from. And all those hormones relate. Now, let's look at the major endocrine gland. You have the pituitary gland. Woo. It controls other glands, stimulus gland. So sometimes we call it the master gland because it's the one that is the chef in charge, controlling other glands. We call that the pituitary gland controls other gland, stimulus growth. Then we have the thyroid gland, regulates metabolism, calcium, and phosphorus. You know the body needs all those things. Then we also have parathyroid gland, controls blood calcium levels, and then we have adrenal glands, release adrenaline during stress. When you're stressed out, the body will release adrenaline. Kind of, you know, push it. Okay. Thank you for sleep. Yes, when the human body is so much complex and you have things that will cool us down. Etc. Yes. Very interesting, right? Any questions so far? You want some short break? Or some 10 minutes to it's very, yeah, very interesting. Yeah. You want some 5 minutes to 10 minutes break? It's really hot outside, so you can't even go out. So let's continue another close by. Right? Yeah, instead of, yeah. Okay, functions of the endocrine system. The role, and that's environmental changes, as I said. When you are stressed out, you know, those kind of hormones are related. Produces hormones affecting bodily function. You know, hormones are very, very good. If you are facing a challenge, hostile environment, they can also activate and prepare you to fight, to counter that danger that's about to come your way. And also, when you are stressed out, they can also, you know, calm you down. These are good hormones. You have the body's reaction to stress. Muscle tense, heartbeat quickens, breathing changes. Anytime you are fighting, what happens? The muscles become very tense. You can see that you are now, you know, ready for action. You are ready for action. Then you see that the heartbeat quickens. Like that. And your breathing will change. Once the heartbeat goes like that, let's assume that, come down. If you are, you know, if you run away and you are able to hide somewhere, let's say somebody with a gun, you hide somewhere. Coming down. Yes. That's what happened. The body is active. Yeah. Now hormones trigger this rapid changes. The hormones have to make the body react. The hormones make the body react to that, to make you to react to that. Then we have hormone distribution. Hormones travel from the bloodstream. Target organs, recognize and accept specific hormones. So you see, when I come to that point, I'm always happy. Why? Because I have something good to explain to you. If you have a headache, I mean, headache is very common that everybody here has ever had a headache, right? When you take some pills, what does a pill do? I mean, what do you swallow the pill? The stomach. Okay. Digest.
And it has through the bloodstream.
Yeah.
And goes straight to where?
Excellent. Excellent. So you see, I like this slide so much. It looks like I've read it ahead of time, right? Yeah, I've read ahead of time. Now, what happens is that, you see, they travel through the blood. So they can target. So when you take that pill or whatever to the mouth, into the stomach, but the system will, tell that it is your head. That's what the problem is. So go to the head. If it is like your waist or your knee, ankle, whatever, it will go to the head. So the same medicine can target here, they know where to go. It's so wonderful. Thank you. Again, God is great. It's so wonderful. So the hormones travel through the bloodstream, target, organs, recognize, and assert specific where they want to go, whatever, they go there. Collaboration with nervous system, brain cells, nerve impulses during threat. Again, you have heard about the brain, right? Everything is about the brain. That is why we learned at the beginning of today's class that when the brain is dead, you are dead. Unless it's miracle. Which have not seen years. But when it comes to God, you can believe in miracle. But scientists don't believe in miracle. They go by sight. Once the brain is dead, you are gone. Even the impulse, the brain again is working. When there is a threat, yes, I said it about several times. I just want you to understand in a very practical way. God goes and again is the brain. So the brain control. So the nerve impulse also, the electrical wiring in the system, again, doesn't work on its own, but work in conjunction in association with the brain. But the brain is the interpreter. Then to command. You fight or flight response. So somebody can be here right now if you're now. Within a proximity like this, you can run. Because by the time you turn, you are gone. At that time, the brain will tell you, listen, fight, do whatever you can to wrestle with that person. You understand me wrong? Yeah. So almost, the endocrine is there just to help you. Endocrine, the hormones. It will prepare you to fight. You don't know where your strength will come from. Right? That's what you said? Okay. You might think you are not strong, but trust me, you are strong. If someone should attack you right now, you don't know where your strength will come. You don't know where it will come from. After that, you also go, wow. So I was able to fight this person. I didn't know I'm strong like that. The hormones have been released to prepare you to fight. Or, no. And you might say that, but if there's a big fight to run, maybe you run faster than you set balls. Maybe. Yeah. You maybe run faster than you set balls. The hormones are working. That's how the hormones work. So they prepare you to either fight or to run. Hormones are very good. During happy times, they make us happy. During stressful bad times, it starts kind of caution. If you're very sad for a very long time, actually had a medical doctor friend who said sometimes when patients come to them and they are very stressed out for a very long time, they, kind of put something, now open their mouth wide. You see, when they are laughing, your mouth opens, right? Like this, open. So the moment that happens, the body interprets that you are happy to release happy hormones to calm them down. That's how this things work. So very interesting. Yeah. Very interesting. Then you have the major endocrine, you have the pituitary gland. It's a pressure gland, at the base of the brain, and then controls other ones, and then stimulates growth, sex organ, development, pressure, blood pressure. Then that is the pituitary, gland. You have the thyroid gland that we mentioned, the neck base. That's where it is. below the larynx, and we also have, under the gland, the adrenal, the pancreas, the ovaries, that's the female. Then you have the testes, and the male sex gland. So we have these glands, located at specific places, We also have the thyroidectomy, removal of all. So these are the surgical procedures involving the endocrine, system. We have the thyroidectomy, the removal of the part of the thyroid gland. Now, we've started processing. We are interested more in the surgical, procedures that go with each system. Oophorectomy, removal of an ovary. Wow. So of course, once you see that will be a kind of like GYN or female kind of, procedure, not male. Then we also have hysterectomy, and that's also the male, section. These are all the, hormone the endocrines. Yeah. Pituitary tumor reception, removal of the tumor on the pituitary gland. Then we have the thyroid section, removal of, nodules or goiters. Some people.
At times I heard people say I have a brain tumor. Is it a tumor in the pituitary gland?
Well, it depends on where it is actually located. Yeah, it could be on the brain itself. It could be the brain itself. Yeah, it could be on the brain itself. Yeah, that's a gland actually. Yeah, but of course, I also I actually know the person. One person who had that, surgery. Travel from Ghana, came here for that, procedure. Yeah, she's on the brain. Oh, yeah, excellent. Yeah, excellent. Yeah. Did that surgery in Mount Sinai, the main Mount Sinai, the base. Yeah, I know that person. Yeah. Then we also have adrenalectomy, removal of one or both adrenal glands, adrenaline, that releases to remove. These are the surgical procedures. Then you have the reproductive system. Reproductive system. Fertilization process. Normally, when I get to this one, I normally don't explain mine because it was the basic science that we all learned in our schools. And I remember when we were in high school, even if strengths, kind of sleeping. Once we get to this chapter, hey, everybody's alert because you want to hear things that we are going to hear. Yeah, so it's very easy. Now, fertilization process. You have the formation of a single cell from sperm and ovum. Here we are talking about the male and then the female coming together. But of course, we are all adults, so we know. Each cell contains 23, chromosomes, so making a total of 46. Yeah. So we have the male. We have formation of a single cell from sperm and ovum. So we should be having 23 from sperm and 23 from the ovum as well. Yeah. So making a total of 46. Now, the male reproductive system, we have the testes located in the scrotum, then the sperm carried from testes to the vas different through the epididymis, and then we have the semen nourishes the sperm. You cannot see the sperm itself. What you see is the semen. The sperm is so much microscopic that you cannot see. What you see is the semen, but the sperm needs to be carried in the semen into the vagina. So you cannot see the sperm. That is what I try to explain. Then we have the prostate gland stimulates sperm fertility. So that's the male. Then we have the female. Then we have the vagina, and then the cervix structure. Then we have the uterus lined with the endometrium, and also we have the fallopian tubes carry over from ovaries to the uterus. Size and tuber. Well, we are going to see some surgical procedures that are associated with this. But these are the basic organs of the male and then the female. Let's begin with the male, the male reproductive system. You have the testes, and then, of course, these are oval-shaped glands located in the skin-covered pouch. And let's talk more about the epididymis and the first different. That's the pathway. That's the pathway. Epididymis carries sperm from testes to the first different. So that becomes the pathway. The pathway. Now, if you go to the book, when you go to page 42, page 42. Page 42, yeah, that's where those things are. Now, five different synthetic wall, each of 18 sperm. Now, again, the good thing is that when you go to the exam, they are not going to ask, biological questions in the exams like epididymis, vast different. No. That's not what central external definitions do. I must be very honest. So that's why I said this whole chapter will be getting about maximum of 3 or 4 questions. Normally, they don't bring a lot of questions from this area, but it will be more aligned to, the surgical procedures. Yes. The question?
How many questions?
150. Those online, one of your classmates is asking how many questions you have in the board exams. It is 150 questions. And the pass rate is so generous, 70%.
Wow.
And when you calculate the 70% of 150, you can use your calculator, is 105 correct out of 150. So generous, almost to tell me. But then, one question can be a game changer. 105, congratulations. 104, sorry. So one question can be a game changer. 104, fail. 105, pass. So one question can be a game changer. So I always inspire us, sorry. Do not underrate anything. Because one question can be so critical in your personal failure. Yeah. But normally, people not pass. If focus and zeal, you should be able to pass. Especially with the teachers we have around. Yeah. Director so much experience into this. John Bosco, who taught you last week, so much experience. Tons of years of experience on his belt. And myself, tons of years of experience in SPD. Under my belt. So there is no way we should just not fail. The class that finished before you, they're just passing like that. Yeah, passing like that. But don't be complacent. In life, we are complacent. Oh, I can pass. Please, my place can come. Don't be complacent. Go for a battle. How many is that a question? 150 questions. Only 150 questions. Seminal, vesicle, and ejaculatory duct.
Hello, sir. Hi, sir.
Hello, Fatih.
So how many hours for the 150 questions?
3 hours. 3 solid hours. Too good. Too good, Fatih. Too good. Have I answered the question, Fatih?
Sure, thank you.
That's great. Anytime. Yeah. So that's about that. But for now, don't even think about the exams for now. You are just beginning. So just wait for when you are getting to the end, we're giving you all this information, right? Yeah. So the seminal vesicle joins with the first difference, to form the ejaculatory, duct, and secretions, of course, that's the seminal. Then we have the urethra, and then the penis, and then so these are the male sex organ. Then we have the female, of course, the vagina, muscular canal, approximately 4.5 inches long, extends from an opening, to the cervix. Then we have the uterus, located between the rectum and the rather hollow pear shape. So these are all the female. Again, they are not going to ask you any question in the board exams. How long is the vagina? No. They will never ask that question. Yeah, they'll never have that question. Yeah. Yeah. Sorry. Yeah, go ahead. Yeah.
I want the surgery name of doing surgery for somebody who has no, it's not hernia. It's about the fallopian tube. Like baby forming of fallopian tube near
Ectopic.
ectopic.
Yeah. Ectopic.
Do they call ectopic? That's the surgery name.
Ectopic pregnancy. We normally have specific traits for those kind of things, but they may no, they actually don't use it.
The surgical name of really
they'll have it on the procedure as ectopic. Patient name ectopic. Yeah, but there is I think you want the name, right?
Yes, if we have the hysterectomy that we know we are going to take the uterus.
Yeah.
This one we are going to take the fallopian tube. So I know it's fallopianectomy.
Oh, I see what you mean. Well, they may not, they may or they may not, but those things appear on the pick list as ectopic, pregnancy procedure. They may have some, instruments, etc. Yeah, but I know that the well, of course, it happened. So don't worry so much again, as I said, about like the typical biology. Yeah, questions are not as on typical biology. Then we have fertilized. Well, of course, I think that's what we're talking about. Fertilized ovum and babes into the endometrium. They're the source of during menstruation of ovum. It's not fertilized. So what happens is that this is how the process takes this process. Then we have the fallopian tubes. The ovidus stand from the two openings, on each side of the uterus. And you can see that in the picture, when you go to the book, well, figure 3.36, figure 3.3, yeah. So on the side, you have some nice pictures, over there. Page 43, just online, page 43. Page 43, you see those nice things on. I mean the book. Okay, surgical procedures. You have the chirurgy relocates a non-discerning testicle to the correct location. Sometimes the testicle moves up. For some strange reasons. They're not willing to descend. There is a procedure, surgical procedure to bring it down. Then you have transurethral resection of the prostate. Anytime we hear the word resection, it's kind of like removing something, Radical prostatectomy. Then the prostate kind of again, ectomy, that ectomy is the suffix, right? What does ectomy mean? Ectomy is a suffix. Ectomy. You have otomy. Okay. Very good. See, this is how I want you to make your teacher last week Thursday happy. This online right now. I know he taught you all this, so when he hears that, you know that you are doing a good job. Yeah, it's online. John Bosco, it's online. Let's go. Then we also have bilateral hemiphorectomy. They also call the bilateral hemiphorectomy. Bilateral, both of the fact correct. Yeah, abdominal ablation. DSC is a very common procedure in the hospitals. Well, I'm not a female, so I don't know, but I heard that in the US when you get pregnant, especially very young, you go to the hospital. I heard the first question you ask you want to keep it? I heard you ask you want to keep it?
It was illegal at first.
Yeah, correct. Yeah, so it's very common DSC and dilation, the dilate opening.
That's injection.
Then we have the ectopic pregnancy that we're talking about. Yeah, which of course, you know. Then the tubal ligation is the one so that we're trying to cut there. Then the vasectomy, of course, that's another there. So these are the procedures, urinary and then the excretory system. The moment you get urinary and excretory system, we're talking about the body discharge of waste material. Yeah, waste material getting out of the body. Remember, we eat. Everybody's eating today, right? Yeah. We drink, so it must come out. So the body filters, it's a filtration system. So the body's filtration system the kidney, B-shaped organs with nephron, network, filters excess water and waste from blood to produce urine. Yeah, so when you drink water, and especially in the winter, you know, someone when you drink, you don't pee too much because of the time. The body needs to store that. It's a cooling system. But in winter, because the body is already cold, when you drink cold water, what happens? You try to pee more, right? Yeah, correct. So the body clears, filters, waste materials out. That is about that. Filters excess water and waste from the blood, and then you have the urethras, tube-like structures connecting kidneys to the urinary bladder, and also called, you know, move the urine to bladder and then move them out. Now, the urinary bladder is the reservoir of point. The next impulse will not be sent to you to tell you that go and pee, because it is a reservoir. It can contain up to some point. I bet you will not be feeling like, you know, now to pee, but when you go there, you can get some pee, small. Of course, you are not feeling it, because the reservoir is not up to the limit of the reservoir yet. So when it's getting to full the reservoir, that's where the impulse will begin to be said that, you know what, begin to think about going to pee. Yes. So that's about that. It's a reservoir of urine located in pelvis anterior to sigmoid column. We have the sigmoid tract. We are going to look, you know, at the 6 areas of the large intestine. So that is how it is. Now, again, the kidneys, we talk about that, and now the urinary bladder, you know, it's a sac, serving as a reservoir. As I said, located in the anterior sigmoid angle. It can average capacity ranges from, if you take okay, it takes cc. Well, you can Google it. 300 cc. You know, it will show up to 7, or you say that during, I mean, the capacity that it will show. So 300 to 500. So that is like, you know, the average. The moment it is getting there, then you begin to have, you know, yeah, the cells kind of telling you that you're ready. Yeah, you need to be correct. Bladder wall, contraction, and of course, physical muscle relation, release the urine. So once you rush in there, the body again tells you that you are now at the urinal. So the urine can come, then it will kind of, you know, contract and then push it. When it contracts, push it. Yeah. It's like a, how do you call this? Then how do you call it? No, people use it to bring theaters, the down the name. You know, bring theater, right? Like some, yes. You cannot know that. It is, you know, something. Yeah, something. It is kind of plastic, right? Yeah, you kind of something like a swing. Yeah, at the tip of it. So you can like squeeze it. This one, is it called?
Do you know, at times when they give birth to a baby, fresh baby, the nurses do something to suck the out.
Something like that. Yeah, you see, when you contract it, it will push something out, right? That's the idea. That's the idea. When you contract, it kind of push that out, and that makes it so good. Now, functions of the respiratory system. Again, continue remove toxic and waste substances from the body. Anything bad, you have taken, maybe you have taken too much soda, like let's say Coca-Cola or Fanta Sprite, and too many minerals to clean them out. And then also includes, the kidney, the lung, the liver, skin. The skin. Summer. A little walk, you see that sweat glands, right? Sweat. Look at these are all the waste things going on. The filters the blood, the liver, that's a very key job. Filters blood and removes amino acids. Neutralizes harmful toxins, then converts hemoglobin from one blood cell to, you see, you can even kind of convert something that is bad into a useful thing. So the liver plays a very key role. Yeah, very key role. Very key role, and that's very important. And then we have the cellular life. Living cells originate from other living cells. We talk about that at the beginning, the living cells live. And these are the surgical procedures. We have a kidney stone shock with treatment, something says somebody has a kidney bone or those kind of things, etc. Nephrectomy involves the removal of the kidney. Doctors and scientists claim, not claim actually that human beings can survive on one kidney. So sometimes people donate one kidney. I don't know if you heard that. So if something they can remove one. The treatment for kidney stones. Use laser shock waves to break down the stones. Stones can also use a stone basket. So these are all procedures.
So if someone gets kidney stones and they do surgery, do they take off the kidney that have the stones?
Oh no.
Do they take the stones?
Treatment and then press out. Correct. Respiratory, breathing. Respiratory. We need oxygen. So the nose. Remember, very critical. We can even breathe through the mouth, but the mouth is not designed for breathing. It's the nose. But if you block this, you can breathe through your mouth. But how long can you do that? That's not designed. And when you breathe in, the air goes into your lungs and then goes down, mixed with blood, whatever. Then the heart will also pump it. Then the 100 trillion cells will get oxygen to be alive. Then you, the human being, will also be alive. That's how it is. So you have the nasal cavity, that's the nose, pharynx, larynx, epiglottis. Then you have the bronchus, and then the right lung, left lung, and the heart. You see, the heart is part of it. Because I said, when you breathe, it goes through this, makes and then boom. Heart. You have the nose, that's very key, and then the mouth. And as I said, we actually don't breathe through the mouth. That's a very when you catch cold, when you catch very serious cold, and sometimes your nose just blocks, sometimes for a few seconds, you like to breathe the mouth. So the mouth is also the pharynx. Air passes through to the larynx and trachea. Then we have the trachea. Well, we are asking for a surgical, we have tracheotomy, and that's what I know you wanted for the fallopian. Whatever you're talking about. We also have the lungs. Then we have the lungs. As you can see, these are the lungs. Over here. The left, then the right lungs. Human beings can also survive on one lung. I know I was working in the hospital, and I know a lady working in housekeeping, who actually had one of her lungs taken out. Yeah, she was alive. Yeah. I don't want to mention the hospital because I mentioned housekeeping. I'm keeping the hospital because I don't want anybody to have any trace to. Yeah, had one of her lungs. So one kidney, look, I'm taking out one lung because back here. Yeah, but we are going to have the two. So I mean for reasons known, by God. So let's work towards protecting them. Then we have the diaphragm contracts and rises to allow air movement. Yeah, that's about that. Let's look at the surgical procedures. We have thoracotomy, opening the thoracic cavity. Yeah, thoracic cavity, the chest wall. Thoracotomy, viewing. By now you know oscopy, right? Last week, I know your instructor John Bosco talked about that. Yeah, oscopy. Yeah, it's a surface. Yeah, visualization. Yes, correct. The visualization. So the view, cavity with endoscopes. Yeah, the view was happening over there. Then we have the functions of supply the body with the oxygen, which removes carbon dioxide. Yeah. Then we have the process of breathing, inspiration, and expiration, like in and out. Then we have, of course, the nose and then the mouth. That's where they play the key roles, and then we have the pharynx. The trachea device, device into right and left of the bronchi. Then we have the lung. The lung is very key, as I said. There's a key role. When the COVID came, in 2020, we were having some people having issues with their lungs, the pressure. So anything that is respiratory doctors were very wanted at that time. Anytime there is a breathing something, respiratory doctors, are highly sought for. They become very high, demand. And these are some of the surgical, proceedings. Bronchoscopy, laryngectomy, lobectomy, tracheotomy, pneumonectomy, etc. Now, the digestive system. The digestive system is also very easy to understand. The moment food enters your mouth, digestion begins. The moment it enters your mouth, it doesn't have to wait to enter the stomach. The moment food lands right there, saliva mixes, pass me. Breakdown begins right there. Breakdown of the food begins. So the breakdown digestion begins from the mouth, technically, scientifically from the mouth. Because when you chew, let's say yeah, just like that, I like so much. I mean, once you put it there, chew once, it's already breaking down right there before it even swallow. Because you cannot chew, but you cannot swallow it like that. Now, requires 6 basic nutrients: proteins, carbohydrates, fats, water, minerals, and vitamins. And again, with the water, that is why it's very important for us to have a very good intake of water all the time, and minerals and vitamins. Some of the food, like the fruits, etc., that we eat, have this kind of things in there. Now, components of the alimentary canal. Now, the entire channel that food passes, the digestion, the whole process is called the alimentary canal. And it begins from the mouth, the pathway. So digestion through the esophagus, you swallow it, then the stomach. That's its base. That is where it is actually going. So most of the work is not going to be done. Through the mouth, through the stomach, that's like a few seconds. You chew a few seconds to swallow. But this is where minutes, hours is going to be done in the stomach. Then we have, so convert food into chyle, the small intestine, major site for digestion and absorption. So for absorption, for the body to be happy, the majority is the small intestine. That's what the key role. That's the key role. And then you have the large intestine, what absorbs water and little. So that also does some kind of little job. But the real absorption then in the small intestine. Then the waste product passes to the rectum to the anus, then goes out, as a waste product. That is the digestion. Then the digestion system, a very nice picture over there. You can see source of energy. Body gets fuel from nutrients in food. Maybe are the basic 6 categories of nutrients. We need all this for our body to be in good shape. We have the proteins that we need. I'm currently, working with a lady who is a vegetarian, who doesn't eat. She was telling me that recently she went to see a PCP, and then the PCP was telling her that her body needs protein. She doesn't eat meat. So, man, I wish she could, give me all the meat in the life. I'll finish everything. I like meat a lot. Yeah. So she doesn't have, proteins in her system. So her doctor advised her that, try to get some protein. Yeah. And then,
I think they take medications.
yeah, of course, yeah. So it's always good to have them. Like you see, medications, technically I'm not the best. So it's good. Well, unless for some reasons you don't want to eat meat or anything. It's not only meat, can fish, like protein. It's not only from meat, can also come from fish as well. Carbohydrates. For carbohydrates, it's very common to get. Well, most of you from Ghana, of course, rice. Rice is popular across the world. Rice you get carbohydrates, like India. But most of us here are from Ghana, and of course, our food is most, food banquet and all those things are here. But rice is, of course, very traditional, and that's fluff, carbohydrates. Yeah, carbohydrates. But fats. I was talking about fats, that when our body breaks down fat, only little is sent out, only little. The rest will be stored. And with due respect, ladies normally stored in their ass. And that's why I said, with due respect. Yes. Yeah, so that's how fat that is why the enzymatic detergent, when we start decontamination, we are going to talk about the enzymatic detergent, having those amylase and lipids. These are enzymes. Because the human, fat to come, fat to be left on instruments, we need enzymatic detergent that can break them as well. So scientifically, fat doesn't go out easily for the body. Only small, percentage, greater part transfer, it will break it down and store at another place. That's why the more fat you take, the more you become big. They tell you to release of fat because fat is not like other ones that will just flush out. That's why fat is so much serious. Today, you are learning this from me that, especially when you begin to grow, please reduce your fat because fat, will break down, transfer, and store at another place. Sometimes your blood vessels inside, it will block it. It doesn't go out. So fat, learn it today from me that it breaks down, transfer, store at another place in your body. So just reduce it.
So the fats that we get, maybe meat.
Yeah, that's exactly what I'm telling you. Yeah, it will store it. Other places. Yeah. So that's not very bad. Yeah. So if you want to avoid having, bloodstream, blood, I'm again with ladies, I'm going to do respect, too much big ass, etc. They try to, reduce your fat intake because it will store them. Now, what is very important because that one, will clean everything out. Then the minerals and vitamins. Strawberry and those kind of fruits. You get a lot of vitamins, vitamin C, vitamin B, whatever, etc. From it. Importance of a well-balanced diet. We know that having a well-balanced diet is very good. Reduce the fat, protein is good, vitamins is good, etc. But the fat is the one that you need to reduce. Having the fast food, French fries, I'm a victim of, as a matter of fact, I like French fries. I don't take it always. Hardly, I mean, once in a while, but I like it. But you know, when, oh yes, when they, it's not the, I mean, it's not the biggest stuff. I'm not a fan, wow, of course, I eat burger, the French fries, I'm a fan of the French fries. If they fry it, it's all about oil. I mean, don't get me wrong, it's not like once a while thing, no. You know, when you talk about fat, you're talking about like, it's like every day, that's what, I mean, your lifestyle, that's what the impact you can. Of course, when you don't take fat, I mean, how can you avoid fat? Even a stew, you know that it's fat, but we are alive. So don't think like, oh, from today, you are, no, it doesn't work. I mean, our body breaks it down. But when it becomes like, for you, your normal routine every day, morning, after evening, like, that's when it begins to affect you to just try to reduce it. Especially the fat, because it is stored in that place. It's not fully eliminated. Only small percentage eliminated, or just stored. Yes. Then the mouth, that's what I mean, digestion begins. I mean, this chapter is a very long chapter, please. You have to bear with me. You know, normally I don't want to go out to the stage because I know you guys sitting down for 3 hours is not easy. But this chapter is very long, so bear with me, please. Yeah. The mouth is there, the saliva, soften the food, the teeth, the teeth. You know this already. I talk about that. Esophagus, the small intestine, the colon, talk about that. Now, a compress of the alimentary canal, the appendectomy, removal of the appendix, and the removal of the salivary, that's parodectomy, then the gastric bypass. Isolating a small portion of the stomach, that's also done. Suturing part of the small intestine to weight, that's also part of it. The twist, morbid obesity. You know, sometimes if you are gaining weight too much, not older people. Older people when they're aging begin to gain a lot of weight. That's like it's natural. We're talking about young kids, 15, 16, 17, 18, 20, going. Some of those you know, are becoming obese, right? Very weak, and they eat a lot. Sometimes, you know, they want to, you know, reduce their stomach. Yeah, reduce their stomach. Very interesting. So that if that person can take 3 balls of pancake, this time the person will just take 2 balls of pancake and will be full. So in that case, yeah, they do all that kind of thing. Yeah, just to make sure that you don't eat too much. Gastrectomy is also there. The rectomy is also there. Now we have primary transport circulatory system delivers nutrient and oxygen to the cell. That's circulatory. Then we are going to talk about the blood, etc. You know. And then we have a lymphatic system, subsidiary of the circulatory system, vital role against diseases. So the blood that we have in our system, you see. When you go for blood work, especially your animal, it's something it takes so many bottles of, you see the small tubes, I mean, a bottle, right? They just tell you to take water. If you tell them, why you don't want blood to take, they just tell you to take and drink some water. No, blood forms a lot quickly when you drink a lot of water. When you study the book, you see that about 5% of the white. Let's go to page come in. Let's go to page 49. Page 49. Page 49. Those online, page 49. Let's look at plasma. Page 49. Plasma. More than 55% of blood is made up of plasma. A yellowish liquid that is composed of water, 92%, and protein. So you see how water is very much important, right? Yes. So you need to drink water. The more water you drink, the more you are able to, you know, regulate. The plasma is there. 92% transport and nutrient waste, and then we have the red blood cells. They carry oxygen and carbon dioxide. Remember, as human beings, we breathe in oxygen and get out carbon dioxide and the waste product, and that's also good for the plants. You know, the plants also use the carbon. You know, yeah. So it's very interesting. Yeah, and the white blood cells, they attack and digest disease-producing organisms. So if your white blood cells are weak, then you are vulnerable to disease because they attack the white blood cells, not the red blood. So the red blood cells, I mean, they are there for oxygen, blah, blah, and the white blood cells, they actually work on attacking and digesting disease-producing organisms. So if you drink, if you drink or inhale something, the white blood cells are there to fight, to make sure that, then we have the platelets, help in blood clotting. If you have let's say a cat, right? Cat, blood is oozing. After some time, she does kind of my clotting and I'm stopping to years. Yeah, that also helps with that. Now, functions of the circulatory system. Yes, even the word circulatory system means that it moves well, correct? I want you to take your cell phone right now. Do something for me. Do something for me right now. Google the distance from New York to California. Now your cell phone, please. Google for me. Distance from New York to California. The distance from New York City to California. How many miles? The distance from New York to California, how many miles?
2,990.
Okay. So let's just make it simply 3,000, right? For easy calculation. How many 3,000s do we have in 60,000?
3,000.
Yeah, how many 3,000 do we have in 60,000? 3,000, how many do you have in 60,000? Yeah, 20, correct.
20.
Yeah, 20, correct. Okay, let's do something right now. So as you sit here right now, the travel the blood is doing in your system is 20 times from New York to California, probably across the world. That's very interesting. If you think about it this way in terms of long distance, then you appreciate all the blood is doing in your system. From here to California, it's not a small flight. I was in San Diego, California. That's a long flight. Correct. Even airplane taking long hours. Blood, 20 times of that. Everyone here right now, that's what blood is doing. You might be wondering, how did scientists know this? Yes. Use the tiniest needle light to pierce anywhere. You see, that will come out. That is everywhere around. They calculated that. That's calculated. Those of you from Ghana, Google New York to Accra, Ghana. Those of you from Ghana, how to contextualize it. Those of you from Ghana, if you're not from Ghana, where you come from, just Google it and see the distance. And Rashid, hello Rashid, please do us a favor. Thank you. 5,000, right? But okay, for easy calculation, let's make it 5,000. How many 5,000 do we have in 60,000? 12, right? You have 12 for that. Those of you from Ghana, look at the distance. About 10 hours flight, Delta from New York, JFK. 12 times of that. That's the travel blood is going to your system. And that tells you how important, the circulatory system. Now, primary transportation network of the body, it transports, delivers nutrients and oxygen to body cells. And remember, the 100 trillion cells, each is having to share the oxygen. Blood is everywhere. 20 times from New York to California. 12 times New York to Ghana. That's the long distance. In fact, to be able to meet the over 100 trillion cells. And the organelles in the cells also need the oxygen. So when you take yourself into perspective, say that, wow, so that's the travel that is right inside you, that's the long distance. Very interesting. And of course, removes carbon dioxide and waste, and then blood is formed through 60,000 miles to the blood. We have the lymphatic system, subsidiary of the circulatory system, like a role the body defines. So we have something called the lymphatic system that is part of the circulatory, and it also helps the disease. Sometimes you have kind of, let's say, cold, not severe one, then you not take anything, and then after some 2 or 3 minutes, it goes by some, the body fights it. The lymphatic system is also helping, as well as the white blood cells. So the white blood cells, then the lymphatic system fought it. Any questions about this? Components of blood. We talk about the plasma, composed of water and proteins, and of course transport, dissolve, nutrients, etc. So that's a plasma. Then we have the red blood cells. We have that as a concave, half concave. Sometimes for flexibility. Let me see. You know, we have something called concave. We have convex. You know how concave? Yeah, curves. Correct. Then yeah. So, but the most important thing is that you should know that it's rich in hemoglobin, oxygen, and carbon dioxide transport, and rich in bone marrow, lifespan 1 to 20 days, 4 minutes, and of course, broken down in liver and spread as spleen. To check all that, and then it can be. So the red blood cells, they survive for 4 minutes, and then they are gone. They have to be replaced, and we learned that. Young cells are formed by existing ones, right? So don't reproduce before the guy anyway. Yeah, they also reproduce. Then you have the white blood cell, twice as large as red blood cells. Lifespan ranges from hours to years. Yeah. I'm happy they last for years because they fight against diseases, right? We just learned that. So we don't want them to be dying every 4 months. That's a plasma. The plasma is for oxygen. That's fine. We'll talk about that, right? But then the white blood cell is to fight diseases, and they last from hours into years. And you have the placement that are also part of. Now, this is the heart structure. We have the heart structure. Vascular organ about the size of a fist, and then pumps and filters blood. A minute. Yeah, it's very long, right? It's a very long chapter. Trust me, chapter 2 is very long. Yeah, chapter 2 is very long. So chapter 4 is not long as this. Yeah, tomorrow. So tomorrow will go a little bit, earlier than this one. It's shorter than this one. Yeah. Now, pumps 5 liters of blood per minute. Woo! 5 liters of every minute. Every minute, 5 liters. Yeah. Wow. That's huge, right? 5 liters. Meaning every 12 minutes, 1 liter is pound. Every 12 minutes. So check 12 minutes, 1 liter to the whole system. Carrying oxygen. Take it from the heart, the respiratory system, to the nose, and to the lungs, to the organ, 100. And Pacemaker in the upper right side controls heartbeat. Some people have pacemakers. It's a medical, procedure. Maybe you have the natural one there. That's the job. Yeah. Then we have heart chambers. Well, we have these are the chambers. 2 on each side. See, you have this kind of thing. See, there's some tubes and etc. Then you have the tubes, etc. Then we have the septum separates right and left sides. And then you have upper chambers are the atria, lower chambers are the ventricles. So we have blood flow process. So deoxygenated. When we say deoxygenated blood, we're talking about the blood that has the oxygen used up. So it is deoxygenated, no oxygen. So blood that has oxygen, moves in the heart, comes to the body, and then the body will send back. After taking the oxygen from it, the deoxygenated comes to the heart, be pumped back, and then mix again. So it just going on and on and on, and it's never ending. It's a very nice process. So blood flows into the right ventricle, valve prevents backflow, and then blood is pumped through the lung, etc. So these are the surgical procedures of the circulatory system. Tonsillectomy, or lymph tissue in the pharynx and throat. Adenectomy, then we have arteriovenous fistula. Arteriovenous fistula. This is also a procedure that you'll be, watching. There are some phrase about that. Situating the radical artery and symbolic vein together in the lower arm, and then allows for large bone needle insertion for renal dialysis. Sometimes when people have their kidneys not working well, they go for dialysis, right? For the blood to be, filtered, purified, yeah, etc. And then we have aneurysm repair. If there is a rupture of like a vein called aneurysm, that then we have the pacemaker, yeah.
I've done it before.
Oh, really? Oh, that's good. Oh, wow. And you see how that is so good, right? Yeah. Okay. Coronary artery bypass graft. CABG, these are all cardiac, procedures. And sometimes,
Hemorrhage.
no, not hemorrhage. Hemorrhage is a general, procedure. Oh, I tell you what. Yeah, hemorrhagectomy, right? Oh, yeah, that's what she's talking about. Yeah, we are talking about CA, coronary artery bypass valve. If there is blockage, somewhere, then they'll create a path to another side of the heart. Yeah, because the coronary artery bypass valve, CABG, it's a cardiac procedure, cardiac surgery. Yeah, they do those procedures. Now, importance of anatomy knowledge for central surgery professional. Well, of course, as we started in the beginning, we talked about having knowledge when the OR operation room communicates, and also help remember instruments names. And some of this, the interesting thing is that some instruments are named after some body places or organs or the surgeons. those who manufactured or who brought them to life. So names are derived from body systems and system diagrams. Then the body functions aids in understanding instrument purposes. And also we have examples of instruments: adenotome, brain spatula. I'll take complete. These are instruments that you don't know for now. Yeah, we have seen them. We have prepped them several years. Then you know how they look like. Yeah. Then the vaginal speculum, a very simple instrument. So this is no, we don't have the vaginal speculum over here. Yeah, no, it's not here. Vaginal speculum. It's a G1N thing. These are the general stuff. Yeah, it has a screw You have the grapes, and then you have the Peterson. And the Peterson is narrow. This is looks like it is a screw that opens when they, in fact, if they want to see the vaginal canal, they put that in, squeeze, and then it will open what the vagina. Vaginal speculum. This is how it appears. You see that in GYN. Yeah, this is how it looks like. Vaginal speculum. This is how it looks like. Yeah.
Family planning. When they want to
yeah. That's how it looks like. Yeah. So again, understand human. Yeah, facilities comprehension, and of course we understand the instruments, and then also how an addressable body systems, anatomical readings where they are used, and learning the body functions aids in remembering instrument names. Of course, we are able to, for example, the brain spatula. You can find that in mirror trays. Yeah, mirror trays, and then you also have a better understanding of instrument purposes, and of course, it helps you to be a technician. Then we have examples of surgical instruments. Okay, acetone. Then we have a brain spatula, aortic compressor, vaginal speculum, instrument. So it will just help you, to be able to know the instruments. Now, conclusion. Now, we started the class today by understanding that we work in human hospitals, not animal hospitals. And therefore, understanding some of the language that the medical doctors use will be very beneficial. We understood that cells, we have about 100 trillion cells, more than that in our system. And cells are the basic unit of life. The three key components of cells, and that's the very summary of today, is that you have the nucleus, which is the brain center of the cells. Then you have the cytoplasm, that kind of cushions, the nucleus. Then you have the cell membrane, which is the outer cap. Then you said that two or more cells form what? A tissue. They're similar. That's the word. The functional structure. That was the time I used the cells from the eye that should be spherical, and then the ears that necessarily or the leg not to be spherical, elongated that they come from. You understand all this? Then we said this time when we came to organ, what did we say? Organ, different, right? Correct, different. Then we go to collection of organs, making out the system. Then this is how we be able to link. Then we began with the skeletal system. The snail. And I said, without the skeletal system, the body will do just a mass of immovable substance. There. And then the skeletal system support. Then we came to the muscular. The muscular, we said, is formed around the skeletal system. When it contracts, it sets the body into motion. We can move. We talk about the central, we talk about the nervous system. That's the electrical wiring of the system. The brain interprets the cerebrum, and then the brain stem. We talk about all this. Then we went on to talk about the digestive system, the alimentary canal from the mouth through the esophagus, stomach, small intestine.
Hi, sir. Hello.
Intestine, and then the rectum, then through the anus.
Hello. I'm lost. I'm lost with the page. The page. Where are we?
We are summarizing.
Oh, okay.
I'm providing the summary. The summary is on the screen, but I'm not summarizing that way. I'm going back in.
Okay. Oh, that's right. I was lost. Okay. Thank you.
I'm happy that you didn't lost. Thank you very much. Yeah. So that's about that. So about the digestive system, and we said, right from the mouth. We said that the body absorbs, the greater part of the nutrients, the whatever, in the small intestine. But the leftovers, some are still absorbed in the large intestine. Then from there, the waste materials goes through the rectum, the rectum, and then through the anus. Then we talk about the reproductive system of the male and the female. We saw that the male testes, penis, etc. are very key, and then the vast difference, epididymis, and then the testes, the penis, these four very key. And then we also talk about the woman, the ovaries, the fallopian tube, the vagina. We talk about all that. We talk about the chromosomes. One cell from the male, one cell from the female, sperm ovum, each one having 23 chromosomes. That determines the genetic characteristics. A very player is a player, and these are players. The genetic. Yes. So we talk about all that. Then we talk about, of course, the circulatory system, the blood, where we said we let the blood flows about 60,000 miles across the system, our body system, and we made some simple computation. New York to California for you to see that about 20 times of that carbon. And we were wondering how black hole, and I said, well, that's just something small, blood is everywhere. So scientists were able to complete that. Then I think that's all that we talk about. Do you have any questions for me? We are finished with this long chapter. One of the friendly chapters to students in chapter 4. And from next week going, there's going to be smiles in this class, I know, because we are going to, study the things that we actually do in summer stuff. Any questions for me? Those online and those in classroom, any questions? Question time.